Algebra 1, Lesson 20, Slopes of Parallel and Perpendicular Lines. In this lesson, we will go over the slopes of parallel and perpendicular lines. There are two basic rules when it comes to how the slopes of parallel and perpendicular lines interact. Parallel lines share the same slope, while perpendicular lines share a negative reciprocal slope. You can also verify by graphing the two equations on the coordinate plane. Here is a graph of the equations y equals 5x plus 2 and y equals 5x minus 6. As you can see, the lines have the same slope, and on the graph it shows that the two lines go on infinitely and will never cross, which is what parallel means. Here is a graph of the equations y equals 5/6 x plus 3 and y equals negative 6/5 x plus 5. As you can see, the slopes are negative reciprocals of each other, and on the graph it shows that the two lines are perpendicular to each other, which means they meet at a 90-degree angle. To clear up some possible confusion, when I say negative reciprocal, I mean to find the reciprocal and then negate it. For example, if the slope of a line is 13, then its reciprocal would be 1 over 13. Then if we negate it, we get negative 1 over 13, which makes it perpendicular to the line with a slope of 13. Make sure to remember that when you negate a number that is already negative, it turns into a positive number. Let's do a few examples to test what you've learned about the slopes of parallel and perpendicular lines. Example 1. Identify if the following lines are either parallel, perpendicular, or neither. Y equals 6x minus 1, and y equals minus 6x plus 7. So, you can tell by looking at the slopes that although the values for the slopes are similar, they are still not the exact same slope, so they are not parallel. The value of 6 was negated, but it wasn't turned into the reciprocal, so it is also not perpendicular, so the final answer is neither. Example 2. Identify if the following lines are either parallel, perpendicular, or neither. y1 equals 2/3 x minus 10, and y2 equals minus 3/2 x plus 3. So, we can identify the slopes of both these lines and can make a pretty good guess that they are perpendicular to each other. If we have any doubts, we could always apply this similar formula. For any line with a slope m, there can be a line with slope minus 1 over m that will be perpendicular to the original line. So if y1 has a slope of m equals 2/3, then the slope of a line perpendicular to y1, which is y2, must have a slope of minus 1 over 2/3. Applying our rules for dividing by fractions, we do in fact get minus 3/2 for the slope of I2, which confirms that the lines are perpendicular to each other. Sometimes you are given one equation and are asked to find another equation that goes through a certain point or points and is either parallel or perpendicular to the original line. These types of problems require some more work, but we'll break them down in a couple of examples. Example 3. Find the equation of a line that is parallel to the linear equation, y equals 7x minus 3, that also goes through point 1, 9. To solve this problem, we need to apply what we just recently learned in this lesson to what we learned a few lessons ago. In this lesson, we learned that parallel lines have the same slope, so we know the slope of the other line is 7. Next, we are given a point that the other line goes through, which is point 1, 9. Now we have a line with a slope of 7 that goes through 1, 9. This sounds like a familiar problem. If you remembered correctly, we solved problems like this in the point-slope form lesson. The point-slope form only requires the slope and one coordinate point, and we are given those, so all we have to do is use that form to create the equation for the parallel line, which is y minus 9 equals 7 times x minus 1. Now for the challenge problem. Insert evil laugh here. Example 4. Find the equation of a line, perpendicular to the linear equation, 2x plus 9y equals 3, that goes through points, -8, 3, and -6, 11. Write the corresponding line in slope-intercept form. This is the last lesson of this unit. You thought I wasn't going to go all out? Let's break this problem down in the next part. So, we have an equation of a line written in standard form, and we need to find another equation that is perpendicular and goes through a couple points, and then write it in slope-intercept form. Now that we know what the big picture is, we can start diving in. First things first, rest in peace, Uncle Phil. Okay, give me a break. These lessons take hours to script. Anyway, first we need to find the slope of the original line, which is not going to be as easy as the standard form, so we need to convert it into the slope-intercept form. Here are the steps. We subtract 2x from both sides. We get 9y equals -2x plus 3. Then we divide both sides by 9. Now we have y equals -2/9 x plus 1/3. So we know the slope of the original line is -2/9, which means that the slope of a line perpendicular to it must be 9/2. Now that we have the slope of the perpendicular line, we need to carefully think about our next steps. In the previous example, we found the slope of the other line and used the point to write the equation in point-slope form. The original problem is asking us to write an equation in slope-intercept form, meaning we must do more work, but let's pick point, -8, 3, and write our answer in point-slope form first. Our answer in point-slope form is y minus 3 equals 9/2 times x plus 8. Now our final step is to convert this into slope-intercept form. First, we distribute the 9/2 to the terms on the right side of the equation. We'll get y minus 3 equals 9/2 x plus 72 over 2 or 36. We need to isolate the y to finish the problem, so we add 3 to both sides. If we did our math right, the final answer should be y equals 9/2 x plus 39. Here is a graph of the two lines from the last example confirming that we did find the right equation. As you can see, the lines meet at a 90-degree angle, meaning that they are perpendicular to each other. And that's it for this lesson. If you could do that last problem, you should be able to do any problem from this unit in the knowledge checks, quizzes, and exams. As always, make sure you get the right amount of practice to build your confidence in understanding these concepts. If you feel a particular lesson or concept might have gone over your head, make sure to re-watch and pause at certain points to review the lecture notes and examples on the screen. With that said, see you in the next lesson.